Welcome to Almost Here, Round the Corner Future Technology podcast with Richard Jacobs. Future technologies poised to transform our lives for better or worse are the focus of this podcast. Almost here means these technologies are now here and starting to be used, or just around the corner, from Bitcoin to artificial intelligence, 3D printing, blockchain, virtual reality, and more. So this is Richard Jacobs with the Future Tech Podcast. My guest is Jarie Bolander, the COO of ISStracks.com, and the company itself is Lab Sensor Solutions. So Jarie, how are you doing today?
Oh, I'm doing great. Thanks for having me.
Yeah, so tell me, what's the premise of the company? What do you guys do?
So Lab Sensor Solutions tracks the temperature and location of perishable medical supplies so they don't spoil. Things like blood, tissue, urine, pharmaceuticals, anything that could spoil if pulled out of you or put into you, like what we like to say. So it's a way to ensure that things are held at safe temperatures and they're at the right place at the right time.
Yeah, I guess that's super important. What's the incidence of lab solutions gone bad or specimens gone bad?
So specimens gone bad, there's a wide variety of data on that. It generally depends on the specimen. But what's called the pre-analytical error rate, which is before it ever gets to the machine, can be anywhere between 5 and 8%. And that error rate could be as simple as, the label was wrong, or it held the sample in the wrong temperature, or the sample didn't get there in the right time. So there's a lot of different types of error rates. And again, it also depends on the sample, the type of sample. Some samples are super time sensitive, like cancer samples, especially blood samples for monitoring chemotherapy. And those error rates at times can be, 35, 40%. So what we are just trying to do is make a unified system to ensure that those things like blood samples get to where they need to go and are held at the right conditions. Because the biggest error rate in the clinical laboratory, the pre-analytical or before it gets to the machine, is sample handling. They don't handle the samples right. So.
Well, what about, I would think, hot climates and, during the summer it gets worse, right?
Yes, it does. And that's one of the things that we see when we deploy our solution to laboratories. We also see that if it gets too cold, if you freeze things, for instance, biology, the cells can burst, and it's not a good sample anyway. But yeah, heat is a big deal. So we tend to pay more attention to things getting too hot.
So what do you do in warm climates or during the summer? Florida, Texas, that kind of stuff.
We put more ice or more dry ice in the container. So our system will tell the courier or the lab staff that, hey, you need to put in more ice. And we can trend it. So if it's a particularly hot day, we can say, hey, bring more ice with you. And occasionally, we'll also see that something will have to be rerouted because it's getting too hot and the driver can't go to the full route. They have to come back sooner. So we try to just make sure that there's, again, a margin of safety, that the sample is properly handled, because that's the most important thing for the result. Bad results of the test.
How can you how do you track? Do you use GPS on on a container that carries a bunch of samples, or how do you track?
So we use the mobile device that the courier has on them. So our solution uses Bluetooth low energy temperature sensors inside the containers. And our business, the majority of our business, the container is held in close proximity to a courier. So pretty much every sample that's handled is in intimate contact with the human when it gets picked up and then when it gets dropped off. So we don't have to really worry about, having GPS on the sensor, we use the phone because we need to know that the container is with the person. That's another important thing, that the courier picked it up and the courier dropped it off, and we know that by the phone picking the sensor up.
Well, what happens if you get a courier that like sits there texting and while the container of all the samples is sitting there in a car, baking or in the sun, or who knows?
So we monitor. So the phone will send the temperature data and the location data up to the cloud, and then we will send out alerts to not only the courier but the dispatcher and the supervisor. So our system is set up to have alerting, so that when temperature hits a certain point, alerts go out. And usually what we found is that when the text message goes out to the supervisor calls the courier and says, "Hey, what's going on? Your samples are too hot." We also provide notifications within our app, so the courier will know if something's going wrong.
So what has this done to the error rates? How many couriers do you have this out to and using, and what have you seen in the error rate reduction?
Yeah, so we have about a dozen customers all around the country. And what we found is that within about 2 to 3 days, we can get the amount of excursion of temperature to go from, let's say, before measuring, which it's hard to measure before measuring, but we see correction anywhere from 3 to 5 times a day, depending on the temperature, and that's during an 8-hour shift. Whereas before there would be no corrections because no one would know. So in terms of being in compliance, we've seen compliance levels go up from what they were before our system, or when we just monitored without people paying attention to it, or without correction. Compliance levels of, let's just say, there'd be events during the day, maybe 5 to 6 events where somebody needed to do something, and then a couple of days later we see those events go to 0, like they correct them before they happen. I mean, obviously there's a distribution of couriers, and sometimes some are better than others, but in general we see a dramatic reduction in out of compliance. Some of it.
Well, I would think there's number of temperature of excursions, and then the duration of the excursion, and then the delta of the ideal temperature versus the actual temperature. So I would think there's like more factors. So have you noticed, how have all those 3 parameters changed in the aggregate?
Yeah. So what we've seen is that since there's a feedback loop for the couriers to know, hey, I need to add more ice and when to add more ice, we see the duration of out of compliance a lot less. I mean, sometimes it never goes, like there's days where it never goes out of compliance because, they're managing it. And then the times it does go out of compliance, the amount of time out of compliance is very short. So our sensor can sense the change in temperature and report it back, every 5 minutes. So whereas before it could have gone a whole run, which a run could be 30 minutes to an hour and a half to 2 hours, without knowing. With our system, within 5 minutes we know, okay, something's wrong, and then add ice or go back to the lab. So yeah, I mean, quantified the amount of time, the amount of duration it's out of compliance is reduced. In some cases, it's eliminated, depending on how good the courier is. The number of excursions are, significantly reduced or completely eliminated, again, depending on the courier. And so that's anytime there's a feedback loop where people can correct themselves, we find that it's a great solution, because now they have the data, they can take action.
Yeah, it makes sense. So how do you monetize this? Is it the labs paying you because they have a lower error rate? Is it the doctors? Is it, who pays? And obviously we know who benefits, patients, but.
Right. So there's two main people that pay for it. The courier, if it's an outsourced courier system, a lot of times laboratories, as an example, will outsource their courier function. Basically the people that pick up the boxes full of tubes. And so in that case, the courier company is our customer, and the end customer, the lab, due to regulatory requirements or due to just best practices for logistics and transportation, require that the courier provide this sort of monitoring. And then we've seen, labs themselves when they have their own internal courier system, like employees, will pay for the monitoring. And the monitoring is obviously helps, patients, but it's also becoming more and more required in the regulatory environment. So there's lots of discussion, so to speak. I guess that's a good way to put it, of how to maintain temperature and sample integrity while in transit. Because they do inside the lab, they have these massive, refrigerators with temperature monitoring, and so inside the lab it's well controlled. Outside the lab, they don't know as much, so that's why they use our system.
What's the consequence of a sample, going out of temperature for a length of time? You said there's an error rate, but will people get false positives, false negatives? Will they get ridiculous data? What will happen?
All of the above. Typically, it's a false negative, and it depends on the test. But a lot of times, it'll show a normal range of something where it could be abnormally out of range. And again, it depends on the test because the chemistry is different. There's lots of different types of tests that run and all sorts of chemical reactions, and they put a lot of preservatives and different things inside. As an example, a blood sample. But generally, what happens is it's a false negative. So like everything's great, and we all know that if it's false negative is in medical is a lot worse than a false positive, because at least then they could check again. So there has been cases where the numbers are just so out of whack, like you're clinically dead, which obviously you're not, right. That they just retest, right? And that's a huge burden. Typically what will happen is the samples will go bad, there'll be wacky results, and they'll make you come back in for another blood test. And so I'm sure, I don't know if you've ever had to go back in for another blood test to get pricked again. Usually that's because they compromise the sample.
Yeah, I didn't know that. And with time-sensitive stuff, I mean, it could be a huge problem for people if this happens.
Yeah. I mean, especially when you're talking about cancer and chemotherapy, those are the highest error rates. And it's partly because the chemistry of chemotherapy and it's, how it degrades and how fast you got to get the sample into testing. But yeah, there's all sorts of tests that really, are time sensitive, temperature sensitive, handling sensitive. And if you don't get them at the right place at the right time with the right conditions, then the tests are wrong. And if the tests are wrong, your diagnosis is wrong, because the majority of a diagnosis depends on blood tests, right?
Yeah. I just read a book on the Theranos scandal. So
yes.
Not that they would have listened, but they certainly could have used you, and it might have unmasked the fraud earlier if they had, or maybe actually made their product a real product. But who knows?
Yes. Yeah. It is. The Theranos thing is very sad, but I'm glad they figured out that they were obviously couldn't deliver, because it's not good, especially in healthcare, to have a promise you can't keep. People's lives are at stake, right? I mean, you have to be very sensitive to that, and it takes time to develop these things, and you want to make sure that you're not hurting anyone.
Yeah, definitely. So what's next? You've got this system in place, which is great. Are you scaling it more, or are there going to be new products that you're coming out with, or new tweaks to it?
Yeah, actually, we are. We're looking to do some consumer products. Our technology happens to be well suited for consumer medical products, where the challenges of keeping things safe and close at hand and at the right temperature and with you. You can imagine there's lots of things that people that have certain medical conditions will need close to them. And so we're working on that, because what we found is that the laboratory business, we know how to handle and know how to report, and the compliance of the medical arena is hard. And to bring that to the consumer space just gives that level of comfort. I mean, this is proven in the medical harshest environments in the medical community. And we know that there's a lot of home medical, say materials, for lack of a better word, that families and individuals need to keep safe and close at hand because their lives depend on it. So we're looking to do more of that because, we really want to help people live better lives. And, all of us within the company have had, family members and sometimes ourselves been in the medical system, and we just know how frustrating it can be if you have to manage some of that yourself. And so we sort of dedicated our career to helping that out. And so far, we're still kicking along and still having fun doing it.
So you said of all the tests you can have, the most sensitive ones are the ones most prone to error because of temperature problems. Is cancer-related ones and chemo-related ones, or are there others that are, problematic?
Yeah, there's any kind of blood chemistry, any kind of like levels of certain, vitamins and minerals. In some cases, like complete blood counts, or things where if you get if the sample gets cooked, obviously since it's a biological process, I'm sure if you've ever, grilled a hamburger or a steak, as the blood in the thing gets hot, it coagulates, and, you're not going to get a good reading. You're going to get the proteins are going to break apart. And so that happens. That's an extreme case, right? When you're cooking meat, it's an extreme case. But in the sample, if it does get too hot, things start to react. It starts to coagulate, and so complete blood count could be off, chemistry panel could be off, chemo drug level could be off, and that's even worse because, chemo has kind of goes through the system in different ways, and it could be affected by different things. And so the most important thing is, you collect a sample, properly handle the sample, and test it as soon as you can.
Right.
And depending on what that test is, the sensitivities could be, it could be all over the map. I don't know if the last time you got your blood work done, but some cases they take blood out of your arm and they wrap the tube in aluminum foil to protect it from light, as an example. Well,
I didn't know that.
Yeah. So, if the light hits it, it's going to change the chemistry. They do ones with some preservatives to make sure that, some of the proteins are there that are preserved. Well, that doesn't get preserved right, or if that gets too hot, it's going to do a reaction. It'll have a reaction. Have, lots of things like that.
What about blood banks and plasma centers? Are they pretty good on how they, collect and get the fluids to where they need to go, or they need help too?
So we have talked with blood banks. Whole blood is a perfect example. Whole blood and plasma, where it's in a bank, it goes to an emergency room, or it goes to a hospital bed or a surgery theater, and they do a pretty good job of transporting them back and forth because it's usually on demand. But they also have been talking to us. We don't have a customer in that arena quite yet, but they've been talking with us about, okay, let's, if you, let's just say, for example, you were going to go have surgery. What they do is they say, okay, it's this kind of surgery. We need 5, units of blood available for you. So if something happens, if you bleed, right, they have it there. Well, they take the blood and put it in a cooler, in the operating room, right? So now that blood's for you. But when you're done, let's say you only used 1 unit or 2 units. Those 3 other units, they need to make sure, hey, can we put those back in the blood bank? Because those blood's valuable, right?
Right.
And so they do a really good job. Most hospitals do a really good job because, it's an intimate thing. Like they take it from the blood bank. Someone walks it. Like organs are the same way. Like literally when you have an organ, it's in a Coleman cooler and it's human transporting it on the airplane, right? I mean, like sitting right next to you. But they're doing more and more of wanting to get more finer and finer granularity as to, what condition was it in? Is this a good organ? Is this blood? Can we bring it back to the blood bank, or do we have to throw it away? So they're working on that.
Okay. Well, very good. So what's the best way for folks to get in contact to find out more about your system and your tracking and to, collaborate with you?
So our website, lsstracks.com, is where our solution is. So that's the best place to see what we're doing. I mean, they can email me. It's pretty easy. It's just Jarie at lsstracks.com. And we're out here in Silicon Valley, trying to figure out how to take the technology that we have and use it for things that will help people. And so that's the reason why we go into medical and these new markets in consumer to help people. But yeah, lsstracks.com is the best place to reach us. So.
Okay. Well, Jarie, thanks for coming on, and the work you're doing is very valuable, important, as we discussed why. So thank you. Thanks for being here.
Oh, thank you. Thank you so much. We really appreciate it. And let's just make everyone healthier again by making sure their samples are okay. So appreciate it. Thanks.
You have been listening to Almost Here, Around the Corner Future Technology podcast with Richard Jacobs. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.